Okay, good afternoon. Let's start. Am I audible? Am I audible?
Yes.
Audible?
Yes, sir. Yes, sir.
Okay, let's proceed then. Last class we have discussed about some project estimation techniques. We have discussed a taxonomy of the different estimating methods. We have discussed about the size estimation. LOC we have seen different other terms such as KLOC, SLOC, and other kinds of terms we have seen. Today we'll discuss about some other estimating techniques. Let's go where we have left. I think this we have started with price to win model. We have discussed analogy model, expert judgment model also we have seen. So now two models are left. Those are top down versus bottom up models, and parametric or algorithm models. Okay, these two we'll discuss today. These things already we have discussed yesterday. Please have a look into this carefully. Already discussed these things. Different expert judgment based techniques such as basic expert judgment, weighted average estimating, consensus estimating, Delphi technique, those things we have already discussed in the last class. So there are actually many techniques of estimating. They can be broadly divided into, or they can be broadly classified into two categories, either top down or bottom up. So, but what is about these techniques? What we have already seen, like price to win, analogy, expert opinion, we have already seen. Will they be fitted under either top down or bottom up approach? Please take this assignment and divide, categorize whether they can be classified as a top down or bottom up, or they cannot be classified on this category. That you please think of. So next model is our algorithmic model, bottom up versus top down model. Then we will see the algorithm models. In design approach, when you have studied design, software design, you might have seen that there are two approaches for designing software. One is bottom up approach and another is top down approach. In bottom up approach, normally we use object oriented design, where first we identify the objects, classes, etc., and then the whole project. But in top-down approach, we follow this. We first identify the main process, then we gradually divide all those things into sub processes or sub modules. So normally the function-oriented design, that is coming under top-down approach, whereas the object-oriented design is coming under the bottom-up approach. Those things you have already studied in software engineering. So in the chapter of software design. So now let's discuss how that can be applied to this project management, how they can be applied to the estimation. So let's first see bottom-up estimation, then top-down estimation. In bottom-up estimation, what you have to do, first you have to identify all the tasks that have to be done. So while developing a project, what are the different tasks? You have to first identify all these tasks, they have to be done. So obviously it will be quite time consuming. So when you can use a bottom-up approach, you can use the bottom-up approach when you have no data about similar past projects. So when no data exists regarding from the similar past projects, then you have to start from the beginning. So better to follow bottom-up approach by identifying all the tasks that you need to do. Let's see when you will apply top-down approach. So as its name suggests, bottom-up approach, it is used when no data is available from the similar past projects. But when you are having similar past projects, similar data you are getting, then it's better to go to top-down approach. So according to top-down approach, you can produce the overall estimate based on what? Based on the different project cost drivers, based on the past project data. So based on the past project data and and by using several cost drivers, you can produce the overall estimate for the project. These various cost drivers we will discuss later on, like reliability, usability, etc. are there. While discussing COCOMO, I will say different cost drivers. What are the cost drivers? So in top-down approach, as its name suggests, first you have to prepare the overall estimate based on the project cost drivers, based on the past project data. So this is the overall estimate. Then what you do, as its name suggests, top-down, go on dividing this overall estimate. So divide the overall estimate between what? Between all the tasks, all the jobs that need to be performed. This is about the top-down approach. So let's first see a little bit about bottom-up estimating. What are the steps? So first you break the project activities into smaller and smaller components or smaller and smaller modules. Stop when you get to what one person can do in 1 or 2 weeks. You cannot go on indefinitely subdividing these components. You have to stop when you expect that yes, this much work can be done by one person within 1 or 2 weeks. Then you stop the breaking procedure. Then estimate the cost for the lowest level activities. First, you have taken the whole project, divided into some sub-modules. Then what you do, estimate the cost required for each sub-module. Estimate the costs required for the lowest level activities. Then at each higher level, calculate estimate by adding estimates for lower level. So because you can take 2-3 levels, then you can combine, you will get the next higher level module. So what you do, estimation. So at each higher level, what you do, calculate the estimates by adding the estimates for the lower level. So one high level may contain, or one high level module may contain 2-3 lower level modules. So what you do, add all. So initial level you estimate you estimate individually for each lower level module. Then in the next higher level you add the estimates which you have which you have obtained for each lower level. So you add in the next level so that you will get the next level the estimate at the next level. So this is how the bottom-up estimating works. Now, in top-down estimate, just the reverse. What you do? First, identify what is the overall project, overall activity, produce or obtain the overall estimate using various effort drivers or cost drivers. Then distribute the proportions of the overall estimate to the components. So after finding out the overall estimate for the project, then you can distribute or divide proportions of overall estimates to what? To the different lower level components. For example, I have identified the overall project. I have estimated that the overall project may take 100 days. Then I have to see the overall project, developing the overall project will require what sort of activities? Like you have to design, code, test. If you want, you can put also requirement specification like this. So these 100 days, from my experience, I will divide it into what are these these three activities. Like I may estimate that design may take 30% of time, coding may take 30% of time, testing may take 40% of time. So when I add these things, I am getting 100 days. So in this way, in top-down estimate, identify or estimate the time or the cost for the overall project using various effort drivers or cost drivers. Then you distribute or divide the proportions of the overall estimate among these lower level components or lower level estimates. This is how the top-down estimates work. This is another example. Here I have estimated what the time at the overall level, 100 days. Then I have divided among the sub components. This is another example where I have estimated that the overall project cost, the total project cost is $500,000. So then I have divided into, I have identified what will be the next level activities like design, program or coding, testing, documentation, producing CD, etc. And then I have estimated that design may take 20% of the total cost, programming may take again 30%, testing may take 40%, documentation may take 5%, producing CD may take under 5%. Then while coming to design, there may be two types of design, your GUI design and database design. Similarly, programming might be, again, it can be divided into 3 types. Documentation again can be 2 types, user manual and your maintenance documents like this. So in this way, and the testing again can be of 3 types: unit testing, integration testing, and system testing. Unit testing may take 10% of this budget, and 10% of this, which one? This is total cost. Unit testing may take 10% of the total cost. Integration testing again may 10% of the total cost. whereas system testing may take 20% of the total cost. So in that way, I have first identified the total cost for the overall project, then divided among the subcomponent. This is how the top-down estimation works. Now let's see the pros and cons of top-down estimation as well as bottom-up estimation. In top-down estimation, it accounts for the system level activities such as what integration of the different modules, documentation of the different modules, configuration management, etc. So top-down estimation can accommodate these the estimations for these system level activities. Many of these may be ignored in the bottom-up estimating method. So these system level activities, estimation for the system level activities such as integration, documentation, confusion management, etc., you may skip or they may be ignored in bottom-up estimation methods. This is one of the plus point of top-down estimating. Also, top-down estimation requires very minimal project details. You require first the overall overall estimation, then you may gradually divide into the lower level components. It requires minimal project details. It is usually faster, easier to implement. It is quite faster as well as it is easier to implement. These are the plus points of top-down estimation. Let's see the minus points, the negative points of top-down estimation. It often does not take into consideration the difficult low-level problems. So, what are the exact low-level problems? At the bottom level, what problems the developers they may face? Top-down approach may not consider those things. It tends to underestimate the low-level problems and overlook the complexities of these low-level components. So top-down estimation, it may tend to underestimate the low-level components and overlook the complexities of the low-level components.
Everyone join on other group, other channel.
Yes, are there two meetings going on here? 19 people are there. Hello. Yes. Here 19 people are there. So is there another meeting? Anybody else can go, or you wait? Let me check with the another one. Please wait. Let's see. There's a power cut actually. That's why I was disrupted. Oh, or you can send message. That is saying that please join the other meeting. Okay, just see. Two meetings now it is showing. Here I'm in there. And 24.
Everyone, please join new channel meeting. Leave general meeting.